Hi guys, this is an introduction to quadratics. Now quadratics start with the x squared function over here. And you see the graph of the x squared function goes like that. Now the x squared function has a very special point at 0, 0. We call this the vertex or sometimes the turning point because that's where it stops going down and starts going up. Now, we can use Now, now we can make other quadratics if we want to have it a different place, right? So let's say we want the turning point to be lower. We can say x squared minus 6. And wait a second, let me get my face out of the way, hit draw. Okay, this is the same quadratics, right? You can see it's the same shape because you go over 1, up 1, over 2, up 4. Because over 1, up 1, 1 is 1 squared. Over 2 up 4 is 4 squared. And it works the same way over here. Over 1 up 1, over 2 up 4. And even over 3 up 9. So this is x squared minus 6. Its turning point is at 0 minus 6. But, so that's how we move it up and down to the vertex. So we can just subtract 6. If we want it up at 8, we do x squared plus 8. But I don't want it 8. Instead, I want it over here at 5, 0. Now that's done a little bit differently. Okay, the turning point is going to be whenever x squared is 0. In this case, to make it at 5, 0, I'll do x minus 5. I'm going to change colors to purple here. Squared. Because this way, when x is 5, y will be 0. I can draw that. And that, now my turning point is at 5, 0. So you notice I have to subtract because I want to make x minus 5, 0 squared. If I wanted it at negative 5, I have to add. So let's say I do x plus 6 squared and hit draw. Now the turning point is at negative 6. That's negative 6, 0. And you can see, get a nice little purple dot over there. Oh, I already used purple for that. Let's change. Get rid of that. I want to change colors to brown. Let's see. There. Now I get brown dot. Good. Now, so if I want to put a turning point anywhere I feel like say negative 4, negative 8, I would do x plus 4, because at negative 4 plus 4 is 0, squared, minus 8. So that'll move it down to minus 8. And my new quadratic will live over there. And their turning point is at negative 4, negative 8. So I'm just going to pick this guy up and stick it in our notes. Like so. Okay. Right after the quiz down here. There we see all of those guys, mostly. Now, we're also, so that's the graphing calculator version of this guy. Now, quadratics also can vary in shape. Let me move this guy out of the way. Now here, we're going to put a vertex of 3, -4. Down here will be the vertex. Oops, wrong page. Sorry. 3, -4. And so we look down here and we see it always seems to have a turning point at 3, -4. And the quadratic oops, be that way. Okay. So this is x minus 3 squared minus 4. You see, it goes from the vertex over 1 up 1, over 2 up 4, over 3 up 9. But quadratics can have other shapes. So we can, for example, have the 3x squared quadratic. You see, in the vertex form, it's 3 times x minus 3 squared minus 4. Now it's going over 1 up 3, over 2 up 9. I mean, up over 2 up 12. That's right, 12. 2 up 12. Okay, now we can have a very shallow quadratic, like here's the 2x squared, by the way, over 1 up 2, over 2 up 8. And this is 1/4 x squared quadratic. So it goes over 1 up 1/4, over 2 up 1. This is the half x squared quadratic. So small fractions make it go really wide, and negative numbers make it go upside down. So this is the negative 2x squared quadratic. Goes down. Okay. So why am I doing all this? This is a shallow, and so the narrower the quadratic, the larger we're multiplying the x squared part by. The wider the quadratic, the smaller the number is that we multiply x squared by. Okay. So the reason I want to get into that is we have a little game here. The idea of this game is to guess what the quadratic is, what the a term be. What do we, all right? So is this a 3x squared, 2x squared, 1x squared? This is a vertical quadratic. It's like a cup, not a mountain. And it's a 3x squared quadratic. So if I click on 3, it says that's correct. This one is upside down. It's like a mountain. The vertex is at the top. So I'm going to look at the negative ones. And so maybe that's a -2, but that's not right. -2 is narrower. -1 is what this one is. This one looks also like the -1. So let's click on that again. No, -1 is too wide, but -3 is too narrow. So by Goldilocks property, we do this in -2. Okay, that one looks like a -3. And that one looks like a -2. It's throwing me a lot of these. And this one looks like a 1. Okay, let's see. Waiting for it to give me a fraction. It's being annoying. There. So this one is definitely one of these negatives. Is it -1/2? No, that's not wide enough. It's the widest one, -1/3. And so that is how this quadratic games work. Now, when you play the game next Tuesday, or whenever it is, depending on which class is watching the video, we're going to play. It's going to give you 2 minutes to see how many you can get right. So if I play 30 seconds, we're going to see that's a -2, a -1, -3, a +1/2, a +3, and I ran out of time from my 30 seconds. You'll have 2 minutes. I gave myself 30 seconds. My score is 15. So you'll have 4 times as much. If I had 4 times as much, I could have gotten 60. Okay, so that'll give you an idea for this. And at this point, we'll stop. I hope you enjoyed this introduction to quadratics.